Okay, today we are going over CC1 2.2.3 review and preview. We're going to start with problem number 46. We're finding the area and perimeter of the figure at right. All angles are right angles. Show all your work. So what I'm going to do is I'm going to break my shape apart. Okay, so for instance, I'm going to say, okay, here's one rectangle. Okay, and using a different color, I'm gonna say, okay, well, here's another rectangle. And remember that the way you break up your shape is not necessarily gonna be the way that I break up my shape, but at the end, we should have the same answers. And then my third rectangle. So I'm gonna start by finding my areas. So 4 times 2 is 8. So the area of my green rectangle is 8 centimeters squared. Okay. Now this whole length is 5, which means when I cut this apart, now it's not 5 anymore. So this up and down is 2. So I have to think, well, 2 plus what is 5, which makes it 3 centimeters. Okay. Which means that this edge of my purple rectangle is 3 centimeters. And I'm going to multiply 3 times a number. I have to figure out what that number is too. So this whole thing is 10. So that means that this purple edge is not 10. It is whatever this 3 plus 4 is, which is 7 centimeters. So 3 times 7 is 21. Remember, it's centimeters squared for the area, which leaves my pink rectangle. So if this part right here that I'm drawing in black is 3, okay? That means that this part here is 7, which makes sense because if I add this 3 plus 7, it makes this 10 right here. But now I need this black length, okay? So we already determined everything up to that point is 7. The whole thing is 10, okay? So I have to kind of imagine that I have a rectangle for the whole thing. Okay, it's actually a square because this whole thing is 10 centimeters. Okay, now the imaginary line is 7 centimeters. What do I have to add to 7 centimeters to get to 10? Well, that's 3. So the dimensions of the pink rectangle are actually 10 and 3 centimeters. So 3 times 10 is 30 centimeters squared. Now I add them all together, and this is just for my area. So I take 30 centimeters squared plus 21 centimeters squared plus 8 centimeters squared. 30 plus 21 is 51. Plus 8, my area is 59 centimeters squared. Now my perimeter. Finding those pieces helped because I need this 7 to help me with my perimeter, okay, and the 3. So my perimeter is the outside edge, and I'm going to add them all together. And as I go, I'm going to highlight each one yellow. Okay, so I have 10 and 3. It's 10 plus 3 plus 7 plus 3 plus 2 plus 4 plus 5 plus 10. I I can use a calculator to help me, or I can just do it step by step. So 10 plus 3 is 13, plus 7 is 20. So 10 plus 3 is 13, plus 7 is 20. 20 plus 3 plus 2 is 25. Plus 4 plus 5 plus 10. So 25 plus 10 is 35. Plus 5 is 40. Plus 4 is 44. Okay, problem 47. Draw and label 2 different rectangles, each with perimeters of 20 units. Do the rectangles have the same area? Explain your thinking. Okay, so I have 2 rectangles. Okay, so one of them I could maybe do 4 centimeters by 6 centimeters. Okay. And the reason I can do this is because I know that 6 plus 6 is 12. And 4 plus 4 is 8. And when I combine them, my perimeter is 20 centimeters. Well, my area is going to be 6 times 4, which is 24 centimeters squared. So now I need to find another one. What could I add together to equal 20? I'm going to try 8. 8 plus 8 is 16, which leaves 4 left over, which means I can do 2 and 2. So my perimeter is still 20, but my area just changed. 2 times 8 is 16. So my area is 16 centimeters squared. The area are not the same. Okay, problem 48. Think about the base 10 blocks you used during the lesson. Using a 100 block, 3 tens blocks, and 6 1 blocks, create a shape with the largest possible perimeter. Remember that the blocks need to be touching along a side, not connected at a corner. Sketch your solution and show all of your work. So, I have a 100 block. And I have 3 tens blocks. And 6 ones blocks. Okay, so right now, before I add my 6 ones blocks, I have 10, 20, 30, because I'm including this line here, 40, 50, 60, 70, 80, 90, 100. Okay, now I need to put these 6 blocks in a way that I'm going to increase my perimeter. So I could put them here. Okay, which means I still have this one here to make my 10. But then I also have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I added 12 to it. So it's 112 centimeters. Can I increase it? So if I take these 2 off here, and let's say I put them here. Okay, so my 10 is still counted here and here, right? So if I highlight it, this is 9, 10. have to redraw some of this, sorry. Okay, this part's 10. Okay, so then I have 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That one did not get bigger. So therefore, if I go back, my largest perimeter is actually going to be this. It's 112 centimeters. Okay, problem 49. Given the data in the table below, copy and complete the histogram to represent families of various sizes. Remember that data falling on a tick mark, 3, 6, 9, etc., goes in the bin to the right of that mark. What that means is if I'm looking here, this is really 0 to 2, 3 to 5, 6 to 8, 9 to 11, 12 to 14. Okay? Now, when I'm putting in my data, I'm going to look. Okay, I'm going to start with Latrice. There's 4. That's going to go in this bin right here, 3 to 5. So she's going to go in that bin. Anything that is 3, 4, or 5 is going to go into that bin. So I have Latrice, Byron, Jackie, and Antonio. So that's 4. So for my height, for 3 to 4, 3 to 5, I'm going to make it go all the way up to the 4. Okay. My next one that I'm going to look at is James, just because he's next in line. So he'll fall between 6 and 8. So I want to find all my 6s, 7s, and 8s. So I have 1, 8, 1, 7, a 6, and another 8. There's 4 again. So it's going to match the height of my other bar. Okay, if I continue down my list, Evan has 2. He goes between the 0 and 2. And my last one is Diamond, who has 11. So my histogram should look like that. For part A, what range do most families fall between? Well, it's a tie between 3 to 6 and 6 to 9. So I'm going to write 3 to 9. Okay. For part B, what range do most families fall between? It's the same question. We are not going to answer that. Okay, do you see any families that are much larger or much smaller than other families? Well, there's one that's between 0 to 3 and one that's between 9 to 11. Those ones are unusual because 8 of them are between 3 and 9. Okay, consider the units in this list: inches, centimeters, feet, yards, meters, kilometers, and miles. For each situation given below, list the units that would be most commonly used to measure the length or distance described. Distance from Bellingham, Washington to Washington, D.C. Well, that's really far. I'm probably going to use miles. The length of a small stuffed animal. I'm going to use either inches or centimeters because miles or yards don't make sense. How far you walk during lunchtime at school? Well, I could probably list feet, but that's a little small. You probably walk a lot more than that. So yards or meters would be a good option. The height of our classroom for number 4. Well, I could use feet. I could use yards. or meters. Those all make sense. I wouldn't use inches. That's pretty small. Centimeters are smaller. Miles too big. So are kilometers. The length of my shortest fingernail. That's really small. I want my smallest units of measurement, which is inches or centimeters. As always, if you have questions, please